In today's video, we'll be looking into the laws of indices. We use laws of indices to simplify algebraic fractions and multiply algebraic terms easily. So let's have a look at the laws of indices first. So these are the 5 laws of indices. But before we go ahead and understand the 5 laws of indices, let's try and understand what an indices is. Indices in singular is called index. An index is any number raised to a power, for example 2 to the power 3. This 2 is called the base, and this 3 here is called the power or exponent. So a base raised to a power, together we call this an index. So when we are saying laws of indices, what we are saying is that the set of laws that we need to know in order for us to solve problems involving indices or indices. We can tell it both the ways. So let's go ahead and understand each law one by one. Starting with the first law, it says a to the power m times a to the power n is equals to a to the power m plus n. Now what does that mean? One thing you need to notice here is that the bases are same. Both of the base is a. So what we are trying to say here is when you multiply two indices with the same base, the powers will add. So if I want to show you an example, say 2 to the power 3 times 2 to the power 2. This is equal to, according to the first law of indices, 2 to the power 3 plus 2. The answer will be 2 to the power 5. Now can we verify this? Of course yes. 2 to the power 3, we know that's 8. 2 to the power 2, and that is 4. So basically what we're doing is 8 times 4, which should be 32. And do we have 32 on our right hand side? Yes, we do. 2 to the power 5 is 32. So we can verify it with an example. But how does it work? What is the reason that the powers add when the bases multiply? Well, to understand that, let's expand this. So 2 to the power 3 is basically 2 times 2 times 2, and 2 to the power 2 is simply 2 times 2. So when you're saying 2 to the power 3 times 2 to the power 2, what you mean by that is 2 times 2 times 2, that is 2 to the power 3, times that by 2 to the power 2, which is 2 times 2. And if you have a look here, this is just simply saying 2 times 2 times 2 times 2 times 2, which is just 2 to the power 5. So from this we can understand that the powers add because that's how many number of 2's there will be when you multiply numbers of the same base. And this is the same reason why it has to be the same base. If it was a different base, for example say 3 to the power 2 times 2 to the power 4. What this would mean is when we expand, this is just 3 times 3 times 2 times 2 times 2 times 2. And you can simplify this. You can multiply 3 times 3, 9 times 2 times 2 times 2. You can go ahead like that. But you can never write this as an index because there are two different bases. Not like in this case. In this case, you had 2 times 2 times 2 and then times 2 times 2. So you can just together write it as 2 to the power 5 because there are 5 2's multiplying each other. This is not the case here, and that is why you can't use the laws of indices when there is two different bases multiplying with each other. So the first law says, and now you have understood, that when two bases multiply each other, the powers add. With a similar argument, we can also say that when two bases divide each other, the powers subtract. So let's look at an example for that. So for the second law, we can say, we'll take a different base this time. 3 to the power 5 divided by 3 to the power 2. According to the second law, this should be the same as 3 to the power 5 minus 2, which is 3 to the power 3. Now let's verify it. So what is 3 to the power 5? 3 to the power 5 is 243. And 3 to the power 2 is 9. So 243 divided by 9 is 27. Now what we have in the right hand side? 3 to the power 3, which is 27. So this example verifies the second law. Now to logically reason why this works, Let's go ahead and expand it one more time. So 3 to the power 5 is saying 3 times 3 times 3 times 3 times 3. Divide that by 3 to the power 2 is basically 3 times 3. This can be rewritten as 3 times 3 times 3 times 3 times 3 divided by 3 times 3. That's because fraction is same as division. A divided by B is as same as A over B, or A out of B in fraction sense. So we can also rewrite this second law as A to the power m over A to the power n, or out of A to the power n. This is equal to A to the power m minus n. So this is also a way to write down the second law, because division can be written both the ways. Now 3 to the power 5 divided by 3 to the power 2, when you divide this, you can see that this 3 cancels out with this 3, and this 3 cancels out with this 3. Now when I say cancels out, what I mean by that is dividing. So this 3 divided by this 3 is 1, and this 3 divided by this 3 is 1. So what remains is just 3 times 3 times 3, which is 3 to the power 3. So what's basically happening is whatever the number of 3 there are at the bottom will cancel out with the same amount of 3 at the top. So that's basically saying the number of 3's at the bottom should be subtracted from the number of 3's at the top, so that we know how many 3's are remaining at the top. So that gives you a logical sense of why division results in powers being subtracted. Because if you have 100 3's, I say 3 to the power 100 divided by 3 to the power 20, what's going to happen is 23's. When you say 3 to the power 20, it's basically 3 times 3 times 3, and it goes on for 20 terms, right? And all of those 20 terms will cancel out with the 20 terms at the top, and the remaining number of terms will be just 80. So what we will have is 3 to the power 80, and that's basically subtraction, 100 minus 20. So what we understand from the second law now is that when the bases are same, and if they are divided, the powers will subtract. Alright, now let's move on to the third law. A to the power m to the power n equals A to the power mn, meaning m times n. And what that means is this is called the power of a power rule. This is called power of a power, right? This is called power of a power. A to the power m is raised to the power n. Let's look at an example first. Let's say 2 to the power 3 to the power 2. According to the third law, this should be 2 to the power 3 times 2, which is 2 to the power 6. Now let's verify if this is true. 2 to the power 3 is 8. So this is basically 8 to the power 2, which is 64. And what do we have in our right hand side? 2 to the power 6. And what is 2 to the power 6? That is 64 as well. So we have verified it with an example here. But what is the logical reasoning behind it? Well, so when you're saying 2 to the power 3 squared, or 2 to the power 3 to the power 2, what you mean by that is when you say 2 to the power 3 to the power 2, this is same as saying 2 to the power 3 times 2 to the power 3, isn't it? Because if you say x squared, that means x times x. When you say 3 squared, that means 3 times 3. And likewise, when you say 2 to the power 3 squared, that should be the same as 2 to the power 3 times 2 to the power 3. And what is this by the first law? This is 2 to the power 6, because you're going to add 3 and 3 because they're being multiplied. So 2 to the power 3 times 2 to the power 3, same base, the base is 2, the indices are being multiplied. So the powers will add 3 plus 3, that is 6. And this is by using the first law, but you can even think about it logically. You can say, well, 2 to the power 3 times 2 to the power 3 is same as saying 2 times 2 times 2 times 2 times 2 times 2. And this is just 2 to the power 6. There are 6 2's multiplying each other. Now if this was some other power, let's say 2 to the power 3 to the power 4, that means I would have multiplied this 4 times. And that means there will be 4 sets of 3 2's, right? 3 2's, another set of 3 2's, and another set of 3 2's. So that's 4 sets of 3 2's multiplying each other, and that's 12 2's. So when we're saying 4 sets of 3, what we're basically doing is multiplying 3 4 times, right? So 3 times 4. And that's the reason the third law implies that we multiply the powers when there is a power raised to a power. I hope that makes sense there. And that's it for this video. We will look into the fourth and fifth law in our next video. If you found this video useful, hit the like button and consider subscribing. And please feel free to comment below if you have any questions or if you have any topics that you want me to discuss in our next videos. See you in the next video.